What's up, fellas? What you just seen right there was the wiggle lead-in. Why is the wiggle lead-in important? Well, when you're cutting really thick metal, the pierce shoots a bunch of metal directly back up into the nozzle. So with the wiggle setting, we are able to make the torch go back and forth really fast at a predetermined distance.
That swash you're seeing is washing away all that crap out of the nozzle.
Okay, fellas, I'm getting ready to cut this piece out, and I've got these holes set to cut at 20 inches apart. And what that means is it will cut one hole and then go a minimum 20 inches away before it starts cutting the next hole. That should minimize the warpage. When you put a lot of heat into stainless steel, it likes to warp on you pretty bad. I've done a couple of samples, and it's looking like this one right here is about the best out of them. So we're ready to go. But nonetheless, this is a very terrifying part of the process, because if something goes wrong, I owe you $600. And heal. Okay, so I spent about a half hour dialing in the settings on this machine, and it was well worth the time. We're approaching water jet quality on these cuts, and this is thick stainless steel. Anybody who's cut stainless is probably in awe that this was done with 45 amps. At least I am. That's just with one tip. I started with a fresh tip after testing. So that's good to know. So I did want to show you guys one thing about plunge rate. You're going to want your plunge rate to be about 100 inches per minute. But you have to go to configuration. Here, let me back up. Go to configuration, homing and limits, and you're going to have to set your Z-axis to 100%. And what that will do is allow your sheet cam toolbox to actually run at 100 inch per minute plunge rate. These are some of the other settings that I use for this cut. The most important feature of all being that of the wiggle. Oh, I'm sorry. Here's to minimize distortion feature that was used. Where is my wiggle? Right here. And that's what makes the machine move back and forth that way, so that the dross doesn't fly right back up into your nozzle shield. Let's take a look at this nozzle shield. This ought to be interesting here. Oh, back to this. Let's see what we got here. After this much cutting, this thing should just be destroyed, like. But it was still going strong. Here, I kind of had it crooked on you. Oh, you just ruined it. Pretty cookie. So the tip itself is pretty much shot. The shield's so wet I can't see anything. That don't look so bad at all. That's just nuts. For this to be that clean after that and aggressive of a show. So, this was a 0.5 inch wiggle. And as you can see, it's quite the pile. This is the 0.125. It was putting out the least.